Hey, Mr. Watt, how are you doing?
Good, Miss Weldon. Ready for this one?
Let's do this. So today we're talking about solar system formation. So last time we were talking about kind of how we thought things were forming over time with the catastrophism and the uniformitarianism, and we're going to apply that to the entire formation of the solar system.
Wow.
Yeah, it's
Okay.
pretty incredible.
Let's take a look.
Okay.
So we've got one learning target here, and that's looking at the 4 steps
Yeah.
that scientists have broken down solar system formation into. So this is a really generalized idea of how the solar system formed.
Yeah,
Let's
absolutely.
take a look. First step.
Okay, so first we start with this thing called the solar nebula. Okay, everything in the solar system started as just this big cloud of gas and dust. And that was really it. Like, you, me, everything that we're made of started as dust, which is pretty incredible.
Okay, so the origin for that dust, part of it would have come from the Big Bang,
Yeah.
right?
Mm-hmm.
And then part of it would have come from solar systems that had already formed before our solar system formed,
Mm-hmm.
and maybe from the decay or the death of some of the stars in that solar system.
Mm-hmm.
So there could be particles in our solar system that came from other solar systems already kind of recycling.
So you and I have both traveled to other solar systems, essentially, because we're made of stuff from other solar systems.
Wish I remembered. Okay, so that's the first step, is you've
Okay.
got this solar nebula, this cloud that's starting to take shape. Let's see what happens to it in the next step.
Yeah, and it says it starts to gravitationally collapse. So we'll see, we get this collapsing. So that nebula, it contracts, and it starts to get smaller and smaller and smaller. And what's going to happen as that contracts and gets closer together?
Okay, so we have to start thinking about what's going to cause it to contract.
Oh, yeah, sorry.
So you've got attractions, gravitational attractions between particles, right? And as those attractions continue to develop, the bigger the particles get and the shorter the distance between them, the stronger they become.
Okay.
So as things start to collapse gravitationally, they're going to also start to spin or rotate. And the effect of that, in the case of our solar system, is that you start to get this flattened out bunch of material
Okay.
that may still be in pockets where you've got some areas that are more concentrated than other areas, especially towards the center where you've got the heaviest concentration of materials.
Okay, so like the most dense stuff is going to move towards the center, right?
The largest volume of materials that's already collected, yeah.
Okay, cool.
Yeah, so that's a good point, because that's going to be really important as we want to think about what happened with Earth itself later on.
Okay.
So the second step here, we came from the solar nebula, now we've got this disk of material that's spinning and that's continuing to collapse under its own gravitational field, right?
Okay, yeah.
Okay.
All right, so next step is we start to get these planetesimals. So you said that things started to group together and collapse together a lot towards the middle, but then you said there was pockets towards the outsides, right?
Yeah.
So what were those pockets turning into, or what was happening there?
So those pockets in themselves are dense areas of matter, and they're going to continue to attract other particles and gases
Okay.
from other portions that are close to them. But they're going to start to distinguish themselves more as separate little, or big,
Yeah.
separate little particles or separate little sections of matter that are distinctive from others that are further or closer to that central big mass. And that central big mass becomes the central big mass that we see up in the sky, which is the sun, right?
That's our sun, yeah.
Okay. But it's still not really the sun we know, even
Okay.
in this step.
So it's like an early sun, and then those little pockets you were saying, they say planetesimals. So
Yeah.
is a planetesimal like an early planet?
An early planet or a protoplanet, sure.
Okay.
Okay.
Okay, so we said 4 steps, so this should be
Yeah,
the last
this will
step.
be the 4th step then.
Yeah. So then we make those planets. So we have all those particles that are condensing and running into each other, and those collisions make those dust-sized particles get bigger and bigger and bigger, and then they turn into full-size planets. Right?
And recognizing we know, because we've all looked at this kind of thing a little bit through middle school probably, that the planets are different sizes, and that the planets are also made up of different concentrations of materials. So
Okay.
the planets that are closest into the sun,
Okay, so like Mercury through Mars.
yep, those
Yeah.
are the planets that we end up calling the rocky planets.
Okay.
We call them the rocky planets because they're made up of the denser rock material. And they tend to be rocky. But the planets that are further out,
So like Jupiter, Saturn, Uranus, Neptune.
and that one that we can't call a planet anymore,
Yeah, Pluto, get out of here. No worries.
he's gone.
Yeah.
Those aren't rocky. What are they?
They're made of gas. So they're actually like just you couldn't really stand on a surface there because there's not solid on the outside.
Right.
Yeah.
So if we think about from the sun, from the center, the most dense material,
Mm-hmm.
the metals, the rocky material,
Mm-hmm.
and then out towards the outskirts of the atmosphere,
Mm-hmm.
we've got the gases. See, I made a mistake. I said the outskirts of the atmosphere because I was thinking about the relationship between the
Oh,
solar
yeah.
system and Earth and the atmosphere. So
Okay,
out
yeah.
towards the outskirts of the solar system,
Uh-huh.
we've got the gases,
Yeah.
just like we've got the gases in the atmosphere.
Oh, so
Of
the
the
Earth,
Earth.
like the formation of the Earth is actually really similar to the formation of the solar system, right?
Yeah,
Interesting.
because
Cool.
it was all the same process that formed the Earth as
Mhm.
the formation of the solar system was continuing, right?
Yeah, absolutely.
Cool. I'm glad it's continuous and it's easy to make the analogy from one to the other.
Mm-hmm.
All
And
right.
when was all this happening, too?
Wow. So we said in the last video that the Earth was about 4.56 billion years old.
Mm-hmm.
And that means that the step 4 had to
Mhm.
happen at that point.
Yeah.
So from that time back to the Big Bang, which I
Mhm.
guess we now believe was somewhere between 13 to 14 billion years ago.
Mm-hmm.
So it essentially took a lot longer to form the early parts of our solar system and our solar system than the actual solar system has been around,
Okay.
right?
Okay. So
That's
like,
an interesting one to think about.
yeah. Okay. Very interesting.
Yeah.
So those are the 4 steps. Pretty straightforward.
Yeah.
And it all started as gas and dust from different stars, which is
And
incredible.
it may end up back there again.
I know. I'm not looking forward to the day. We won't be around.
We won't
though,
be
right?
around.
Yeah.
Yeah.
Okay. All right. So now we got to compare this to uniformitarianism and catastrophism.
Yeah.
So, I mean, remember, uniformitarianism was something that's happening now, has always been happening.
Mhm.
Small processes. So, like, what small processes would be happening with the nebular hypothesis that are still happening now?
So you want to think about the way the denser material
Mm-hmm.
is moving towards the center of mass,
Okay.
and the lighter materials are staying further from that center.
Okay.
That
So kind of differentiation. Yeah.
So we see that on a lot of different scales,
Mhm.
not only in the solar system, but
Mhm.
if you look at just small scales within in things that you can see on a daily basis.
Mm-hmm.
So that, I would say, is not catastrophism. It's not one simple event that
Mhm.
happens over a short period of time. It's just ongoing throughout time.
Yeah.
So uniformitarianism for that particular event. But
Okay.
are there things in this that maybe would be considered catastrophes?
I would absolutely think so. At one point, we didn't have a moon before, and there's actually some pretty solid evidence that said another early planet ran into us and actually like forced our moon to form. And so that seems like it's a pretty isolated event that happened relatively quick.
Yeah.
So that would be a catastrophe, right? Cool. And like even like meteorites hitting our planet or
Sure.
like hitting the moon.
Yep.
Okay, so those are all catastrophes.
Yep.
They happen relatively quickly, but they still happen a little bit, not as much as they used to. But
So just like with other things in Earth's history, you've got examples of uniformitarianism and catastrophism that have worked together
Mhm.
to shape what we have today.
cool.
Cool. All right, so that's the end of this section, the end of the intro chapter for you guys. Go up, hop out to your class website, take your third quiz. Remember to go back to the video, pause it if you need more help. Go back over those steps. They're also in your book. If you want to look at it in the book quick too as you're taking the quiz, probably a good idea. Good luck.
Yep. See you guys tomorrow.